Hello, and welcome to the fifth lecture in the OxRAM Robot Arm software lecture series. And today we're going to be talking about ROS actions. Okay, so today we're going to cover what ROS actions are and how they work. We're then going to define a new ROS action, much like we defined a ROS service last lecture. Then we're going to have a very brief introduction to what object-oriented programming is and why it's useful, before creating our first ROS action client-server pair. Again, much like what we did with the ROS services. And finally, we'll have a brief introduction to launch files that will be useful for you going forwards into developing your own systems. Now, again, a reminder for the to have the lecture slides and the example code on hand while you follow along with the lecture. Now, what are ROS actions? So they're a request response system like the ROS service, but this time with feedback. So the client node sends out a goal and awaits a result. So the server node listens to the goal and it processes it while giving feedback back to the action client as it's processing, and then sends a result back to the client when it's eventually finished doing what it's doing. So this is much better suited for processes that take an extended period of time. While ROS services are meant for fast processes, this is meant for processes that might take a few seconds or longer. For example, getting a robot arm to move from point A to point B. You'd want to use an action for that, not a service. Now, let's consider an abstract action that we might want to do. So for this example, we'll specify for how many seconds that action should be carried out in our goal. We're also going to want to have feedback telling us the number of seconds for which the action has been carried out. And finally, at the end of this action, we're going to want to receive a result that tells us whether the action was completed successfully. So I'm here in Ubuntu, and we first, much like in the case of the service, the ROS service, defined here, we're going to want to define our action. So you're going to want to create a folder called action, like that. And inside that, you're going to want to create a file called example.action. Now, the reason it's called example.action and not example service.srv like I defined here is because ROS adds action onto the end of whatever you've called it. So if I said example action here, it would be called example action action. So that's why there's a little break from the convention here in this specific case. Now, similar to how with the service we defined a request and response, in the action we first define our goal. So here in 32 seconds requested. And then we define our result after the 3 hyphens. So we define the result after the goal here. And this is going to be Boolean, saying, true or false, whether or not it was successful. Once the action's finished. And then finally, we define the feedback. So again, this is going to be another int32. You could, make this a float, and you could have it continuously send a stream back of the seconds that's been elapsed so far. So that's going to be the structure of our action messages. And again, as with defining a new service, we're going to have to edit our build files in order to actually build this action type, so that we can use it in our code. So we're going to have to come back to cmakelist.txt first and go to, where was it? Here we go, near the top, about line 10-ish. So underneath message generation, you're now going to want to add a new another package called actionlib_messages, because in order to make actions, you need this specific package. Now down here, you're going to want to uncomment the section for generating actions, and we want example.action as the action file that we're building. So that this corresponds to this file here. We're going to want to build this file so we can actually use that action. And again, so under generate messages, we're going to want action lib messages as well as just standard messages here, because we're making actions. We're not just making a normal message or a service message. Back down in catkin package here, line 105-ish, we've got action lib messages here. So that's another addition. And yeah, that should be everything. So just make sure what you've done is the same as what's in the lecture slides, or what I've done here. And now we're going to go to package.xml, and what I've done is I've added 3 lines. So this is what we added for service, but now we need to add these 3 lines for actions, and each of them are pertaining to action lib underscore messages. But we've got a build depend, we've got a build export depend, and we have an exec depend. This is going to be important for being able to build the action. So once you've made those 2 changes, and obviously you've added the new action definition, we're going to go run a new terminal. It's going to load up a tutorial workspace. Catkin build, rebuild the workspace. This time we're building the action as well, and it succeeded. Wonderful. So yeah, our action is built and now we're ready to start making some code for it. Now, before we continue with the actual code, we should have a little look into object-oriented programming, because we're going to be using this in one of the scripts that we write. So in time, you'll see that the action server that we've made is implemented as an object. So objects in OOP are complex data structures with their own internal data and methods. So it's more complicated than just an int or something. You're creating an object which has within itself data, and it also has functions specific to that object that can operate on input arguments that you give it, and also the data that's stored in the object. Now, classes are the blueprints for these objects and define the data and methods. So an object is an instance of a class. Now, these concepts are the basis for object-oriented programming. If you're into computer science, you'll know what this is, but for everyone else, this is a very important fundamental design, a form of design in when you're developing code. So onto the code itself. If we look here in scripts, I've already made the action client and action server code. Again, I would recommend typing this yourself, and you can find the code in the GitHub repository. So I'd refer to that. But I'm gonna go through it now to give an explanation as to what's going on. We'll start with the server. So we import ROS.py, and now we're importing action lib as well. And we're importing from tutorialscripts.message, we're importing the example action that we've defined, example feedback, and example result. So these messages are used, in this ROS action system. So yeah, this action server is going to be implemented as an object. So a few things to note for when you're defining a class in Python. All your data variables are going to be prefixed by self. So if we look here, we're defining an action server object within the action server class. And you can see it's self.a_server. So, but if you wanted to have if you wanted this class to store a number as well, maybe you would have to say self.x or self.whatever you want to call it, So there's that. The definitions of all methods need to have self as the first input. So here we go. So this is a method that we're defining, execute callback. And although goal is the only thing you'd explicitly write, self, you should always have self as the first input. And calls for the methods must be prefixed by self. So for example, Is there an example of it here? I'm not sure if there's an example of it here, but yeah, that's also something to bear in mind. Okay, now to access the data and the methods outside the data structure, you replace self with the name of the object. So a good example here is, oh, actually we don't do that either here. But that's another thing to if you wanted to extract some data from your class, and it's public data, so it's not hidden from you. You can say, I don't know, in this case it would be s.x. You know, if the number is if our number is stored in a data field x within, you know, our class. If that makes sense. So that's how classes work in Python. Now onto the particular class here. So we've defined this class called example action server. Now we should first define an initializer function. So this runs when we call the constructor for a class, when we actually instantiate an object here. So when we run s equals example action server in the main code, this function is going to be the first thing that runs. So what happens is we define, in this case, we define the action server object, so a underscore server, and then we're going to use actionlib.simpleActionServer. So this is a constructor for an action server object. And the name of the particular action service that we're going to run is example underscore AS. And it's of type example action. So this is the particular name that we've given to it, but this is the type of action that we're going to be doing. That makes sense. Kind of like when I said example service 1, but that's of type example service. When we were doing ROS services, it's the same thing. And here we're defining the callback that we need to do. So the execute callback equals self.execute callback. Here you go. Actually, this is the example of that I mentioned of how the methods need to be prefixed by self, because the execute callback is a method that we will look at next, but we have to prefix it by self here inside the class definition. And we're going to say auto start is false. And then we're going to add, because then we're going to manually start. So the auto start is set to false because after we've instantiated the action server object here, we're going to then start it up. So now let's have a look at the callback. So that's run. So this callback is executed when the action server receives a goal from the client. So self, and then the goal is the actual, this is what we get from the client. So we're going to define a few things here. The reason I'm not having to do self.feedback, self.result, etc. is because these aren't stored in the class. These objects are only going to exist for the duration of this callback, right? If I said self.feedback, it's then going to create an object that we'd then be able to access, in other things. But because these, I don't really care if these get destroyed at the end of this callback. We don't need to say self.feedback, self.result. But if you wanted to, you'd have to do that. So these are going to be temporary variables, just for the sake of this function. So we're instantiating the feedback variable, and then we're instantiating the result variable. And note that these are taking us special ROS action message formats. And for this case, we're going to make the result always be successful. So we're just going to immediately say that the result.success, so the success entry in result, if we have a look at action here. Yeah, so note that success is the name of the thing. So result success, that's because we called it success in the result entry in the definition for our example action type. So we're going to say that's true immediately. We're going to set it to true. And we're also going to define a ROS.py rate. And what we're going to use this for is this is going to be the rate at which we publish feedback. So what we're first going to do is we're going to put in terminal. We're going to say that we've received the action request, and then we're going to start performing the action. So then we're going to do a nice simple for loop, just for for each second that we've requested that the action go on for, we're going to check if we've cancelled the action. So what this will actually do is this will change the success to false. So it's going to fail the action if we cancel the action, and then it's going to break from this for loop and return the success or failure. But if we're not going to cancel the action, which we won't do, we're going to set the number of seconds elapsed to I in the for loop, and we're going to publish this feedback. So seconds elapsed. This corresponds to this here, and and seconds requested is from the goal here. So that's how those come into play. So we're going to publish the feedback, and then we'll sleep for a second, and then increment the counter. So that's basically we're counting up from 0, 1, 2, 3, 4, 2, whatever. Now, once we've done this for loop, so this is at the end of the action, we're going to say if the action was successful, we're going to increment the counter a final time, just for that's just for it's like simple the logic of the problem, because we're not going to do feedback and the result. We're going to say it's going to say it's going to do, for example, if we've requested 5 seconds in our goal, the feedback will go for second 1, 2, 3, well, for 0, 1, 2, 3, 4, and then the 5th second is going to be when we actually give our result back. So that's why we increment the counter, because this is the last second that we're actually providing the results rather than just feedback. And then we're going to say the success, and then we're going to set the action server to succeeded with what the result was. And then this is going to return it back to the client. Okay. So going back to here, this is how you publish feedback, and this is how you publish a result. So in this case, set succeeded, or we can do set aborted. So in the case where the action failed, we're going to give a log error saying the action was aborted, and we're going to actually set aborted as the result here, as opposed to set succeeded. Then finally, in the main code, we just initialize our action server node. Then we call the constructor to actually create the class. We'll create an object of the example action server class, which has all of this, these methods and data fields defined within it. And then we're just going to spin ROS-Pi to make sure that the node doesn't close, so that node doesn't exit immediately. It's going to continuously wait for new actions. So that's how that works. That's the server. Now the client is, I think it's a bit more simple. Yeah, we're not actually using a class structure here. So we're importing ROS-Pi action lib, and then importing example action, example goal. This is we're defining the callback function that the client's going to run every time it receives feedback. Because when the client receives feedback, you're going to need to do something with the feedback. So this is going to allow the client to dynamically respond to whatever the server's doing. In this case, we're just going to say that it's received the feedback, but you could make it maybe do something a little bit more complicated if you want. Maybe if it's gone on for too long, the client can think, cancel, and then it would say like you'd send a cancel request that would kill the action. We'll kill that the processing of the particular goal that you've sent out. Okay. Here we define a function to call the server. So I guess we could have actually just put this in the main body of the code, but it's it's good practice to define everything in its own function, in its own methods, and then just call those methods in your main body. Because that means you can also import these methods into a different Python script, maybe if you wanted to. But what happens in call server here is we're first going to set up the client. So action lib simple action client, and the particular action here is going to be example_as. but the type of actions can be example action. Now we're going to wait for the server to become available. So it will wait here until it detects that this node's running. Well, it's going to wait for a server for example action server. Now, we then will set up a goal. So our goal is going to be of type example goal. And then we're going to fill in what seconds request is. So here we're doing something a little bit funky. So the input function in Python basically means that the user will be prompted for an input in the keyboard. So it's going to ask for how many seconds should I perform the action. So this is what it's going to write out in terminal, and then we'll give a number between 1 and 9. And well, if we don't, it will force it to be within 1 and 9 here. So this is a little catch if and elif statement to force it to be within between 1 second and 9 seconds. But that will make up the seconds requested entry into our goal. And then we're going to send the goal. So client.send goal, and then the goal that we've made here, and we're going to say that the feedback that it should the feedback that should be carried out, the feedback callback that should be carried out is this function that we've defined here. So it will use this every time it gets some feedback, and then we're going to tell the client to wait for a result, and then here what we're going to do is we're going to retrieve the result once it's available. So result equals client.get_result. So that's how you retrieve the result message once it's been returned to the client from the server. And in this case, because we've defined a function here, we have to have a return of the result. We need to return the result. So the result is going to be the output argument of this call server function method that we've defined. And then what we're just going to do is we're going to get the terminal to say what the result that it's received is. So either true or false. And if there was an exception raised, if the request was failed, or something, we'll instead put an error saying that something went wrong, and then the particular error or exception that's going to be what's stated after that. So that's how the client works. So now it's time to test this ROS action client server pair. Okay, so it's time to test our ROS action client server pair. So first what we're going to do is run ROS core. Okay, and then let's first run the server. Cool, and it's going to just be waiting. ROS run scripts client. Okay. Oh, .py. There you go. Yeah, that's why I forgot the .py. Okay, now look, we're now getting a prompt here for how many seconds should I perform the action. That's exactly what I said for it to request the use to ask the user in the code. So let's say 5 seconds, and then enter. So there you go. Exactly as we would have expected. So you can see here, as soon as we gave that input, that was taken as what's going to be the goal for this action. And so the client sent out this goal, which was received by the server. So you can see action request received, seconds requested is 5, as it should be, and then it's going to be performing the action. And then it was silently performing its action on this side, and publishing feedback every second, which was then being received by this action. So which was received by the client. So the client every second was receiving feedback, which we can see here. So it's after 0, 1, 2, 3, 4. So it was executing that feedback callback every time the action server was putting out feedback. And then finally, when the action server finished its job, and it was successful, nothing wrong happened, nothing, it didn't fail, it was successful. It then, publishes success, action complete after 5 seconds. And then sent this back to the client, and then the client says, result received, success equals true. So we can see that the client gave the goal to the server. The server was continually giving feedback, and in the end, the server gave the result back to the client, and the result was true. I just want to take this opportunity to point out that a lot of the time when we invoke the log info method, or the in the client, for example, log info, square number received, all that stuff, that's for the sake of clarity for these examples, right? So that means we can see exactly what's going on from terminal, and we can watch the whole process unfold for the sake of learning. And in practice, you don't need to have log info everywhere. I'm trying to make it very explicitly clear what's going on in terminal when we execute these programs. But we could really clean a lot of this up. We don't really need all this information if we know what's going on. So in practice, you would not need square, for example, square number. Oh, well, actually, if we go back to the actions, if we go to the action server, go to the top here, action request received performing action. You can just delete that. That doesn't actually do it. It just tells us something, But when you're debugging code, or when you're making code, it's often very useful to include stuff like this so that you can observe what's happening, and if something's going wrong, maybe you can figure out what's going wrong by reading the log info that you're getting your code to publish onto the terminal. Useful for debugging, but I've really made everything really explicit in these examples, and I wouldn't imagine when you're developing, when you're actually developing something, for you to need all of this information being streamed into terminal. So let's take a quick interlude and look at launch files, which are, when you're developing larger ROS projects, you're really going to want to start using launch files to make your life a lot easier. So launch files allow you to execute multiple programs at once. And they also allow you to specify different launch arguments and parameters for your programs, rather than having to type it all, step-by-step manual into terminal. Just run the launch file and it will do it all for you in sequence, It really streamlines the process. And you can have launch files within other launch files. So you can build up these really complicated systems from simpler ones. So you can you can create subsystem by subsystem, test each subsystem with their own launch files. And then you can have one large overarching launch file that runs those other launch files that you've made in sequence. So that means ultimately you would only have to run one line in terminal, and then it would launch all of these launch files, and then each one would execute all those programs. I hope you can imagine how this would scale quite nicely. If you're working on this big robotics program, you could boil it down to, I don't know, launch robot, and then all the programs that you want to use, just all the nodes, just get launched using the launch files. So what we're going to do now is we're going to create a launch file for this action client server pair, specifically just for the server, and then we can launch the client whenever we want to. Actually carry out an action. So what we're going to want to do here is we're going to want to create another folder in tutorial scripts called launch. So this is going to contain all of our launch files. And inside this folder, what we're going to do is we're going to make a new file called example action server.launch. I believe that's right. Yeah, that looks right. Okay. Oh no. Damn it. I pressed there you go. Okay, so now what we're going to do is we're going to make the launch file. So XML. So this is what you need at the top of your launch file, because a launch file is it is an instance of an XML file. So it's not really a programming language per se. It's more I think it stands for Universal. I can't remember what it stands for, but yeah. But we need to define what it is by with this top bit here, and then just for clarity, space there. So launch. Node name equals example action server node package equals tutorial underscore scripts, and the type equals example action hi, and then a couple more arguments. Respawn equals false. Output equals screen. Okay. So, and let's just test that this works, shall we? Before I make a fool of myself. ROS launch tutorial scripts example action server.launch. Okay, there you go. This is why you check your code. I've got a problem with my keyboard where it's putting too many P's in when I press P. It might be one of the keys is stuck. But okay, now it should be fine. Yeah, okay. And then we're going to run the client again. There you go. There you go. So you can see that here that it's actually that the server is running, but we've run it through a launch file. Let's talk a little bit more about that now. We've got this launch. So launch, and then inside this launch section, we say node, and then the name. So this is going to be the name of the node. So example action server node. Now this will override the name that you gave the node in the code for that specific node. So what you'll notice here is ROS node list example action server node. However, here we actually called it, we used _e example action server node. So what's happened is the launch, if we go through the ROS launch, it's actually overridden the name of the node to be example action server node like this. And now so then you also need to define the package that it's from. So the package is tutorial scripts, obviously. And then the type. So what type is it's asking you what it needs to run. So in this case, we want to run the example _action _server Python script. What respawn means is if you quit the launch file, it will like restart again. You don't want that. So respawn equals false, and output equals screen basically means that it will print stuff to terminal. If you say output equals, if you don't have output equals screen, basically it won't give any information in terminal. But we want to be able to see what's going on, so we've set output equals screen. Cool. So yeah, that's how launch files work. And what's interesting is you may have noticed that I didn't have ROS core running. I didn't have to run ROS core separately. If you run ROS launch, it will automatically start up ROS core, which is, that's nice. So we don't need to bother doing it every single time. So that's reduced the number of things that we have to run to 2. Actually, and one last thing that I want to do is I want to just show ROS action list. Is that going to work? No. Okay. Maybe ROS topic list. There we go. Look. Because we've got the as we mentioned before, the type of action that we're doing is this example action that we've defined. But with the particular action that the action server is promoting is example underscore AS. So once again, this is a parallel to how with the ROS service we had example service 1, but that was an instance of the type example service. And then you can see feedback goal, and you can listen into each of these things. So let's say ROS topic echo example /feedback. Hopefully this will work when I 2 seconds. Yeah, see, look, it's actually reading the feedback, and hopefully, as you can see here, the actual message is quite a little bit more complicated. It's got a lot more going on than just the ints and the strings and the bools that's the data that we want to send. There's a lot going under the hood to make all of this work. Okay, to finish off, let's just have another think about the 3 different methods that we've learnt about so far in this lecture course for communication in a ROS system. So the first that we learned, and the simplest, is the publisher-subscriber system. So again, this is a many-to-many system that allows for one-way communication, but it makes up the basis for all ROS systems, including services and actions. They all work off of the publisher-subscriber system, under the hood. Then we go to ROS services. So this is a request response system, and it's got 2-way communication, so they're back and forth. But we want to use it for requesting fast processes. Meanwhile, ROS actions are a request response system with feedback. So again, 2-way communication here, but this is used for requesting extended processes. So these are the 3 different methods that you'll be using for communicating between your different nodes in your ROS system. Now, in summary, we've gone over what ROS actions are, how they work. We've gone through defining a new ROS action. We did a little look at what OOP is and why you use it. We created a ROS actions client server pair in Python, and we ran it, and we saw how it works. And finally, we had a little brief introduction to launch files, and how we made a launch file for the server that we made. So your homework for this lecture would be to revise ROS actions, how they work, go over the code that we've gone through today. Make sure you can understand everything. Next time, so in the last lecture for the software lecture series, we're going to learn how to create autonomous behavior for robots using state machines. So that's all for lecture 5, and I hope you enjoyed it, and I will see you in the next lecture, which will also be the final lecture of this 6 lecture series. So thank you and goodbye.